In this experiment, to determine the acceleration of freefall g, we're going to use two light gates, A and B, connected to a computer to time an interrupt card as it passes through them. We will set up the software to give a calculation of the acceleration. The light gates work by having an infrared sensor and an infrared LED creating a beam that can time how long the beam is being interrupted for by the card. Whilst we're going to get the computer to work out the acceleration on its own, it's important for us to realise how the computer is going to do this. So if we look at a velocity against time graph, we should know that the gradient of this line will be the acceleration. Now, as the card starts to fall, eventually, at the beginning, it will start to break the first interrupt card at this time, and then as it passes through, it will finish interrupting the first light gate at this time. So, because we've got a delta t, or time difference here, delta t, then and we will have told the computer the size of the interrupt card, so what it will do is it will work out what's the average velocity that it passed through the first light gate. Then, a short time later, the interrupt card will start interrupting light gate B, and it will pass through it because it's got the same size card, and because it comes in at a faster speed, it's not going to take as long to get through, and the computer times that, and from that it works out a second velocity. So the first one we would call u, the second one we would call v, and the computer would also take the time difference between the two, halfway between each one's interruption, and from that it is able to calculate the gradient of the line.